UVM tutorial. The UVM Universal Verification Methodology is a standard to enable faster development and the reuse of a verification environment and the verification IP (VIP) throughout the industry. It is a set of class libraries defined using the syntax and semantic of SystemVerilog IEEE 1800 and is now an IEEE standard. The main idea behind the UVM is to help the companies develop modular, reusable and scalable test bench structures by providing an API framework that can be deployed across the multiple projects. UVM is mainly derived from the Open Verification Methodology (OVM) and is supported by multiple EDA vendors like Synopsys, Cadence, Mentor, and Arctic. The UVM class library provides general utilities like a configuration database, T-element component hierarchy, in addition to data automation features like copy and print and compare. It brings in a layer of abstraction where every component in the verification environment has a specific role. For example, a driver class object will be responsible for only driving signals to the design, while a monitor simply monitors the design interfaces and does not drive signals to that interface. The image below shows how a typical verification environment is built by extending readily available UVM classes, which are denoted by the UVM star prefix. These components already have the necessary code that will let them connect between each other, handle data packets, and work synchronously with others. So it goes through many revisions where new features are added and some older ones duplicated. The reference manual for UVM can be obtained here, and a content description on class hierarchy, function, and task, and might become overwhelming for new users because an extensive API available for implementation. So it requires more disciplined approach to understand the framework part by part. Hopefully, you will find the information these pages useful. Thank you. This UVM instruction. What is UVM? SystemVerilog is a language, just like Verilog, and has its own construct, syntax, and features. But UVM is a framework of SystemVerilog classes from which fully functional test benches can be built. There is only one prerequisite to run UVM, and that is SystemVerilog, because it is the foundation for the tower that is UVM. Why do we need a UVM? Primary, the advantage is that the methodology specifies and lays out a set of guidelines to be followed for creation of verification test benches. This will ensure test bench uniformity between different verification teams, cross-compatibility between IP and standalone environment integration, flexibility, and ease of maintaining test benches. For example, there can be many different ways to implement display messages and control verbosity with different settings such as running, error, and debug. In UVM, the underlying reporting mechanism has been standardized and made available so that the engineers can instead focus on the most important part of their job, which is design verification. Another example is the sequencer driver handshake mechanism is taken care of under the hood, so the only stimulus
needs to be written. This saves quite a lot of time in setting up a testbench structure since the foundation itself is well defined. What does UVM help? Every verification testbench has a few key components like drivers, monitors, stimulus generators, and scoreboards. UVM provides a case. UVM provides a base class for each of these components with standardized functions to instantiate, connect, and build the testbench environment. These static entity called components in a verification environment that exist throughout a simulation, just like buildings in a city. These components operate and process on some kinds of data that flow around the environment similar to people and vehicles in the city. The data or transactions are called object or sequence items, since they appear and disappear at various times in the simulation and is more dynamic in nature. So what is the UVM class hierarchy? The UVM provide a base of a set of base classes from which more complex classes can be built by inheritance and adding onto in certain functions required for verification environment. For example, a new driver class for Wishbone protocol can be built by extending the UVM class base class UVM driver. Stimulus for the protocol can be written by extending from UVM sequence item. How this sequence is built and handed over to the driver is taken care of internally by the UVM framework. UVM avoided the base of all classes, but it is primarily empty. UVM object is the main class in which common functions to print, copy, and compare to objects of the same class are defined. There are two branches in the hierarchy. The first one contains classes that define verification components like driver, monitor, and the last shown in the diagram as everything underneath UVM report object. The second one defines data object consumed and operated upon by verification component shown in the diagram as everything underneath UVM underscore transition. Major UVM class categories. UVM object. The idea behind UVM is enhance the flexibility and reuse code so that the same test bench can be configured in different ways to different components and provide different stimulus. These new user-defined configuration classes are recommended to be derived from the UVM underscore object. For example, a configuration class object can be built to have certain settings that define how testbench environment has been built. Next, the UVM sequence. UVM also introduces the concept of a sequence, which is nothing but a container for the actual stimulus to the design. If you put different stimuli into different sequences, it enhances the ability to reuse and drive these sequences in random order to get more coverage and verification results. All, all new user-defined stimulus classes are recommended to be inherited from UVM sequence. Yeah. As a sequence can be used inside other sequences to create different scenarios. For example, individual sequences can be created, one with each for read and write transactions. They can be used in random pattern in some other sequence to perform RWRW or RRRW, WWRR, and other similar patterns. UVM sequence items. Data object. that have to be driven to duty are generally called as sequence items and are recommended to inherited from UVM sequence item. For example, sequence item class can be defined from a PB transaction that define what the address, write-read data, and the access type should be, and send it to an APP driver to drive the transaction to duty. The UVM component, all major test bench components are drive, derived from the corresponding base class. For example, all new user-defined driver classes are recommended to be inherited from UVM driver and monitor classes from UVM monitor, and so on. A brief description of what each UVM component does is given in the table below. The component UVM driver, UVM monitor, UVM driver drives signals to duty, unit monitor signals at the duty output port, and create different test patterns, contain the sequencer, driver, and monitor, and contains all other verification components. A checker they determine if test passes and failed, and subscribe to activities of other components. Register layer. Registers designs support control registers that can be configured by software, and this has been the very challenging in SystemVerilog test bench because for each project you had to build a separate set of classes that can store and configure these registers. UVM has an extensive set of classes to make that task relatively simpler and belong to something known as a register model. This is very useful in verification of IPs that can be reused in various SOC designs. TLM connections. Another really smart feature is the use of TLM from systemc. TLM helps to send data between components in the form of transactions and class objects. It also brings a way to broadcast a packet to each listener without having to create a specific channels and attach to it. UVM phrases. Another main features that verify components inherit from their parent class UVM component is phrasing. This enables every component to sync with each other before proceeding to the next phase. Phases are covered in the next chapter. Every component goes through to build phase where it gets instantiated, connect with each other during the connect phase, consume simulation time during the run phase, and stops together in final phase. To recap, major classes. Class of UVM object define method for common operation like copy, compare, and print, typically used to build the test bench and test case configuration. UVM component, all test bench components like driver, monitor, scoreboard, and etc. are indirectly derived from this class. UVM sequence item or sequence items that need to be sent a driver to be driven onto the bus are extended from their classes. UVM sequence or sequences that define the stimulus or test cases are extended from this class. Thank you. See you next chapter.